Hi there, Mr. Sutton here, bringing you the IM3 Honors 3-1 Extra Practice Solutions on Intro to Imaginary Numbers.
To simplify this radical, we need to take care of the negative inside by taking an I outside. So this can be rewritten as I radical 50, positive 50. And then 50, the biggest perfect square that goes into that is 25. So we can split this up into radical 25 times radical 2. Square root of 25 is 5, so this is then 5i radical 2. To simplify this one, we need to take an I outside the radical to take care of that negative. So we can write I radical positive 24. And then the biggest perfect square that goes into 24 is 4, 4 times 6. So we have radical 4 times radical 6 that we can split that into. And then the square root of 4 is 2. So we're going to have 2i radical 6. To simplify this one, we need to take care of the negative inside the radical first by factoring out the square root of negative 1, otherwise known as I. So we can rewrite this as I radical positive 320. And then we need to simplify the 320 inside the radical a little bit further because there's definitely some perfect squares that go into that one. By trial and error, you might find that the biggest perfect square that goes in there is 64. This is really 64 times 5, but you could break it down by taking out 4 one step at a time. So I'm going to write this as radical 64 times radical 5, and then the square root of 64 is 8, so this is 8i radical 5. To simplify this one, we're going to take that negative out as an I, so we have I radical positive 54. And then 54 can be split up into radical 9 times radical 6. 9 is the biggest perfect square that goes into 54. Square root of 9 is 3, so this is 3i radical 6. We can't simplify this radical until we take an I out. So I'm going to rewrite this as negative 5i radical positive 45. Taking out that I is really just factoring out the square root of negative 1. So now that we have a positive inside, we break it up like we normally would. 45, the biggest perfect square that goes into that is 9. 9 times 5. So we have the square root of 9, which is 3, times negative 5i. That's negative 15i. And then we still have that radical 3. On this one, we have to take care of that negative inside to simplify the radical. So I'm going to take that out as an I. So I'll write negative 7i radical positive 150. And then 150, biggest perfect square that goes into that is going to be 25. Radical 25 times radical 6. That's how I'm going to split that one up. Square root of 25 is 5. 5 times negative 7i is going to be negative 35i. And then we still have the radical 6. To simplify this power of I need to figure out where I am in the cycle of 4. So let me divide 86 by 4, and I'm only really interested in the remainder. 4 goes into 84 evenly, so dividing 86 by that gives us a remainder of 2. So then I to the 86 is equivalent to I squared, and I squared is negative 1. To simplify I to the 74th, we need to figure out what power of I this is equivalent to in the cycle of 4. So let's divide 74 by 4 and see what the remainder is on that. Now 4 goes into 72 evenly, so this is going to be a remainder of 2 then, if you divide 74 by 4. And that means that I to the 74th is really the same as I squared in terms of the final answer. And I squared is negative 1. To simplify this power of I, we need to know where we are in the cycle of 4. So if I divide 72 by 4, the remainder on that is going to be 0 since 4 goes into 72 evenly. So since we have a remainder of 0, that means that I to the 72nd is equivalent to I to the 0. And then I to the 0 is just 1. To simplify I to the 67th, we need to know where we are in the cycle of 4. If I divide 67 by 4, I end up with a remainder of 3 because 4 goes into 64 evenly. So 67 divided by 4 would be remainder 3. And this means that I to the 67th is equivalent to I to the 3rd. And I to the 3rd is just negative I. To find the value of I to the 77th, we need to know where we are in the exponent cycle of 4 for i's. So if I divide 77 by 4 and find the remainder, Well, let's see now. 4 goes into 76 evenly, so that means 77 divided by 4 would give us a remainder of 1. This means that I to the 77 is the same as I to the first, which is just I.